This is our solar panel system. The circuit diagram of our solar system is panel solar is connected to controller and then connected to battery, and battery is connected to inverter, and lastly inverter is connected to load. Okay, I will discuss each of component. Firstly, the component is a solar panel. The function of solar panel is produce the electricity by get the sunlight. And then solar panel is connected to controller. The function of the controller is control the voltage of the solar. So in this case, our solar panel is produce 18 volt, and then the controller will step down the voltage to 12 volt to make sure our battery is charging. And then controller is connected to the battery. The function of the battery is store the power energy that produced by the solar panel. And then battery is connected to inverter. The function of the inverter is step up the 12 volt of battery to 220 volt, and then inverter is connected to load. So this is our load. Okay, for the energy we produce, we use the solar panel is like 10 watt, and then we use 2 solar panels, so the total is 20 watt. And then the energy produced by per day 20 watt multiplied by 4, and we can get 18 watt. Why we multiply by 4? Because average average sunlight of Malaysia like a 4 hour, and then 80 watt we can charge 12 handphone and or 2 laptop. Okay, let's go to demonstration of our solar system. Like now, we try to charge our solar panel at 4 p.m. And this I will show how it can charge in our system. We can see from the controller. It show the solar panel is charging to battery. The voltage is 13.4, and then this is try to charging the battery, and we can see this battery is totally full charge. Okay, this is about our load, which is inverter will connected to the load, because inverter will step up the voltage to 220 volt. And then I will show what the load we use. Firstly, we use the lamp. I will show. If I turn on the button, it switch on. And then the second load is about plug, which is we use 3 plug. And if I turn on for plug input, our input will charging. Okay, this is about our load. Okay, for the first IoT, is we control system MCB, which is we can turn on or turn off the MCB. For the skirt, we use the ESP and the relay. The function of the relay to cut off the voltage, and then the function of ESP to control the relay if we want to turn on or turn off. Okay, let's we do the demonstration for our IoT. Okay, firstly we can control the lamp on off. I will push the button on, and then the lamp will on, and then I try to turn on the plug, which is can charge in my handphone, which is I turn on, and then wait. Okay, and then we try to turn off. Okay, it's not charging my handphone, and then I try to turn off the lamp. Okay, so this is IoT for control the MCB system.
So for the second part of this project, we have the hydropower system, which consists of 5 components, and the main components we have here is our own designed water turbine. We designed it from the PVC pipe and a rod. So for the second components, if we have the timing belt, which is connected to the alternator, which can rotate the shaft of the alternator. And for the third components we have here is the bearing, which support the rotation for the water turbine to become faster. And the main part of this system, we have the alternator, which produce the electricity, and then the battery, which is to store the power generated from the alternator. In this video, we will demonstrate the functionality of the hydropower system using water as the source of the power generation. The water will rotate the water turbine, then rotate the shaft of the alternator, which is connected to the timing belt. In this case, the water pressure becomes the main factor, whether it can rotate the shaft fast or slow. The more the water pressure, the faster the shaft can be rotated, then more power can be generated from the alternator. Using the multimeter, we can see whether the alternator charged the battery or not when the shaft is rotating. The voltage increasing means that the battery is charging from the alternator. The load motor will indicate if the battery is charging or not. If the load turns on itself when the alternator shaft is not rotating, that means the battery is discharging, and vice versa.
Assalamualaikum and good morning. This is IoT for balancing and monitor percentage of the battery. Firstly, we use 3 battery, which is 2 battery from solar and 1 battery from the hydro. For this case, if the first battery percentage lower than 25, the second battery will support the battery to up to 25, and then if the second battery is less than 25, the third battery will support to up to than 25. Why we do a balancing like this? Because mostly the function of balancing to take a long lifetime of the battery. If we use the battery always less than 25, it make the life cycle of the battery is short. I will do the demonstration. Okay, for demonstration, we check the percentage of the first battery, which is the percentage is 75%. Okay, we can see. Okay, if it's 0%, the relay will turn off. Okay, you can see the relay. Okay, but if it's 75%, the relay will turn off. The function of the relay to cut off the percentage, cut off the balancing of the battery. Okay, and then we try to second battery. Okay, we can see. Okay, we can see the percentage of the battery is 50, and then we can see the relay is one of the relay is turned off, but I take off the relay is turned on. From this we can conclude the function of the relay to cut off the voltage from the balancing. So from this IoT, I can control the battery to make sure the battery not less than 25. And why we don't do balancing for third battery? Because we will make sure the hydro is continuous 24 hours. That's why we don't do a balancing for third battery. Okay.